Okay, for question 7, we have the situation here where we have two blocks and we have a spring. These two blocks are being compressed, and then it's basically asking us, then it's going to be released, right? And it's asking us what's the potential energy that this spring has um, when it was being compressed, that was stored in it. And it's also asking us for the final speed of A once this is released. What's the final speed here? So we have some given information. We know that the mass of A is 3 kilograms, the mass of B is 6 kilograms, and we also know that the velocity of B is going to be 1 meter per second. Something important, we're going to use the conservation of momentum. The conservation of the initial should be equal to the conservation of the final. And then that gives us, we know that momentum is mass times velocity, so 0 is going to be equal, there's no initial momentum, so it's going to be ma va plus mv vb, and then basically we start solving for va, which is the final velocity of block A, and you keep solving for it, and then you end up getting va is equal to -2 meters squared, right? So what that tells us is that over here, this is going to be moving 2 meters squared that way, right? And it's negative because it's going the opposite way. If this way is positive, if the right is positive, then the left side is negative. Okay? Now to find potential energy of the spring. So something to know, we know that the mechanical energy of A is going to be equal to the mechanical energy of the final, of the initial and the final. And we know that it's going to be we're going to have 0 0 of kinetic energy of the initial plus the half kx squared, and then that's going to equal half of mav, right? All the stuff we did before, ma mva, half of mv mbb squared plus 0, and we just start plugging those things in, and we get that the potential energy is going to be equal to 9 joules. And that should be everything.